There are cases when a routing protocol learns of more than one route to the same destination. To select the best path, the routing protocol must be able to evaluate and differentiate between the available paths. For this purpose a metric is used. A metric is a value used by routing protocols to assign costs to reach remote networks. The metric is used to determine which path is most preferable when there are multiple paths to the same remote network. Each routing protocol uses its own metric. For example, RIP uses hop count, the IGRP uses a combination of bandwidth and delay, and Cisco's implementation of OSPF uses bandwidth. Hop count is the easiest metric to envision. The hop count refers to the number of routers a packet must cross to reach the destination network. For R3 in the figure, network 172.16.3.0 is 2 hops, or 2 routers away. Note: the metrics for a particular routing protocol and how they are calculated will be discussed in the chapter for that routing protocol. The metric parameters. Different routing protocols use different metrics. The metric used by one routing protocol is not comparable to the metric used by another routing protocol. Two different routing protocols might choose different paths to the same destination due to using different metrics. Play the animation. RIP would choose the path with the least amount of hops, whereas OSPF would choose the path with the highest bandwidth. Metrics used in IP routing protocols include hop count, a simple metric that counts the number of routers a packet must traverse. Bandwidth influences path selection by preferring the path with the highest bandwidth. Load considers the traffic utilization of a certain link. Delay considers the time a packet takes to traverse a path. Reliability assesses the probability of a link failure, calculated from the interface error count or previous link failures. Cost, a value determined either by the IOs or by the network administrator to indicate preference for a route. Cost can represent the metric, the combination of metrics for policy. We have discussed that individual routing protocols use metrics to determine the best route to reach remote networks. But what happens when two or more routes to the same destination have identical metric values? How will the router decide which path to use for packet forwarding? In this case, the router does not choose only one route. Instead, the router load balances between these equal cost paths. The packets are forwarded using all equal cost paths. To see whether load balancing is in effect, check the routing table. Load balancing is in effect if two or more routes are associated with the same destination. Note: load balancing can be done either per packet or per destination. How a router actually load balances packets between the equal cost paths is governed by the switching process. The switching process will be discussed in greater detail in a later chapter. Play the animation. R2 load balances traffic to PC5 over two equal cost paths. The show IP route command reveals that the destination network 192.168.6.0 is available through 192.168.2.1 serial 0/0/0 and 192.168.4.1 serial 0/0/1. R 192.168.6.0/24/120 via 192.168.2.1 0 hours 0 minutes and 24 seconds, serial 0/0/0 via 192.168.4.1 0 hours 0 minutes and 26 seconds, serial 0/0/1. All the routing protocols discussed in this course are capable of automatically load balancing traffic for up to 4 equal cost routes by default. The IGRP is also capable of load balancing across unequal cost paths. This feature of the IGRP is discussed in the CCNP. Multiple routing sources. We know that routers learn about adjacent networks that are directly connected and about remote networks by using static routes and dynamic routing protocols. In fact, the router might learn of a route to the same network from more than one source. For example, the static route might have been configured for the same network /subnet mask that was learned dynamically by a dynamic routing protocol, such as RIP. The router must choose which route to install. Note: you might be wondering about equal cost paths. Multiple routes to the same network can only be installed when they come from the same routing source. For example, For equal cost routes to be installed, they both must be static routes or they both must be RIP routes. Although less common, more than one dynamic routing protocol can be deployed in the same network. In some situations it may be necessary to route the same network address using multiple routing protocols such as RIP and OSPF. Because different routing protocols use different metrics, RIP uses hop count and OSPF uses bandwidth, it is not possible to compare metrics to determine the best path. So, how does a router determine which route to install in the routing table when it has learned about the same network from more than one routing source? The purpose of administrative distance. Administrative distance AD defines the preference of a routing source. Each routing source, including specific routing protocols, static routes, and even directly connected networks, is prioritized in order of most to least preferable using an administrative distance value. Cisco routers use the AD feature to select the best path when it learns about the same destination network from two or more different routing sources. Administrative distance is an integer value from 0 to 255. The lower the value, the more preferred the route source. An administrative distance of 0 is the most preferred. Only a directly connected network has an administrative distance of 0, which cannot be changed. It is possible to modify the administrative distance for static routes and dynamic routing protocols. This is discussed in CCNP. An administrative distance of 255 means the router will not believe the source of that route and it will not be installed in the routing table. Note: the term trustworthiness is commonly used when defining administrative distance. The lower the administrative distance value, the more trustworthy the route. Click Show IP route in the figure. The AD value is the first value in the brackets for a routing table entry. Notice that R2 has a route to the 192.168.6.0/24 network with an AD value of 90. The 192.168.6.0/24 90/2,172,416 via 192.168.2.1 0 hours 0 minutes and 24 seconds. Serial 0/0/0 R2 is running both RIP and EIGRP routing protocols. Remember, it is not common for routers to run multiple dynamic routing protocols, but is used here to demonstrate how administrative distance works. R2 has learned of the 192.168.6.0/24 route from R1 through EIGRP updates and from R3 through RIP updates. RIP has an administrative distance of 120, but EIGRP has a lower administrative distance of 90. So, R2 adds the route learned using the EIGRP to the routing table and forwards all packets for the 192.168.6.0/24 network to router R1. Click Show IP RIP database in the figure. What happens if the link to R1 becomes unavailable? Then R2 would not have a route to 192.168.6.0. Actually, R2 still has the RIP route information for 192.168.6.0 stored in the RIP database. This can be verified with the Show IP RIP database command. This command shows all RIP routes learned by R2, whether or not the RIP route is installed in the routing table.